Chapter 5, Number 1. An object of mass m is initially at rest. After a force of magnitude F acts on it for a time t, the object has a speed v. Suppose the mass of the object is doubled and the magnitude of the force acting on it is quadruple. In terms of t, how much time does it take to accelerate from rest to the same speed v now? So, we should probably figure out its acceleration and connect that to how t relates to v. So, we have a couple of things. We definitely will have that v is at, where a is the acceleration, but we'll also have that the net force, which is F, is ma. So a is F over m. And we put this up here to get that v is F over m times t. Or, inverting that equation, we have that the time is mv over f, which is kind of neat. Also, as a sort of future thing, this relation turns out to actually be quite deep and interesting in physics when we get to chapter, I think it's probably 9. So a while down the road, but we'll come back and talk about this in a different context. All right, so then if we say that our new time, which I'm going to call just time 1, some other time, is going to be the mass at that other time over the force at that other time times the velocity. But we know stuff because we know that m1 is twice. So this is really 2m, where m is our original mass. And the force is quadrupled, so this is really 4f. And we don't do anything to the speed, we want to do the same speed, so we still have that there. And then we can group this slightly differently, and we group the 2 over the 4, and we get 1/2. And then we're left with mv over f, but notice that equals is equals. So mv over f is the same as saying just t. So the new time to get to speed v is 1/2 the original time. We can look at this as saying that doubling the mass by quadrupling the force, if we go over here, if we go up to the top here, doubling the mass by quadrupling the force means that a became twice as large. And if it has twice the acceleration, it takes half the time to get to any given speed.